In this section, we will be learning about polynomial function basics. In level 1, we will start off by defining what a polynomial function is. We've seen lots of polynomial functions before. They will actually be pretty familiar. What a polynomial means, poly means many, and nomial is many terms. So something like y equals 2x plus 5 has two terms. Or we could have a polynomial with more terms than that, like f of x equals 3x to the 5th plus 2x to the 3rd minus 7x plus 1. This one has four terms. So polynomials have as few as one term, and they can have many terms. The notation for a polynomial function looks complicated. So I've popped in an image, but the notation is p of x equals a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus, there could be a bunch of terms in the middle, a sub 1 times x plus a sub 0. And all of those a's are any numbers. So a sub n minus 1, they are any real numbers. They can be fractions, they can be decimals, they can be irrational or rational. But the highest exponent that shows up on a polynomial, which is n, tells us the degree of a polynomial, and we'll be getting into that. And then the very last a value, a sub 0, is a constant term. So some examples of polynomial functions would be the ones I wrote above, but any function where the coefficients, or the number in front of the variable, are any type of number. So I could have a fraction, like 1/2, and I can have x to any whole number power. So the powers need to be positive or 0, so x to the 7th would be okay. And the powers are not allowed to be fractions or decimals. They cannot be negative. So I could have 1/2 x to the 7th plus 2.5 x to the 3rd plus 12, something like that. So it can have as many terms as I want it to have, but the exponents have to be whole numbers, so no fractions, decimals, or negative numbers for the exponents. But again, the coefficients, the numbers in front, can be any types of numbers. And the domain for every polynomial will always be negative infinity to infinity. We can plug any number we want in for x in a polynomial function. Graphs of polynomial functions have to be smooth, and they need to be continuous. So they are curvy and smooth. They don't have any sharp corners or cusps, and they don't break apart, so there's no gaps, and there's no holes. So the figure on the left is an example of what a polynomial function might look like. The figure on the right is not a polynomial function because it's got some sharp corners, a cusp, and it breaks apart and has a hole. So that would not be a polynomial function. If we think about our parent functions that are polynomial functions, we have quite a few. So our polynomial parent functions would include our constant function, like y equals some constant like 2. Our linear function, y equals x. Our quadratic function, y equals x squared. And our cubic function, y equals x cubed. Things that are parent functions that are not polynomials would be anything with a corner or a cusp, like y equals the absolute value of x. The graph of the absolute value of x has a sharp corner, so that would not be a polynomial function. Y equals the square root of x is actually x to the 1/2 power, and since that exponent is a fraction, that is not a polynomial function. For the same reason, y equals the cube root of x is not a polynomial, because that's x to the 1/3. Y equals 1 over x is not a polynomial function, because this actually equals x to the -1. We have a negative exponent. So if you ever have variables in the denominator, it's not going to be a polynomial function. And the step function is also not going to be a polynomial function. It breaks apart. If you remember, the graph kind of goes. So it's definitely not continuous. Now we are going to name some different polynomial functions. The degree of a polynomial function is the highest exponent that shows up in the function. So if you have f of x equal to a constant, so f of x equals a, an example would be f of x equals -3, our constant function. This is like -3x to the 0 power. So the degree is 0. Remember that x to the 0 is 1, so we wouldn't write x to the 0. We would just write f of x equals -3. That is our constant function. And the graph is a horizontal line. Our next one is our linear function. A is the coefficient, and this is x to the first power. So the degree would be 1. An example of a linear function would be like y equals 2x plus 5. The exponent on our x would be a 1, so that's a first degree polynomial. It's linear. It makes a straight line that might be increasing or it might be decreasing. Our next one, if our highest exponent is a 2, a degree 2 polynomial is quadratic. So something like f of x equals 3x squared plus 5. It makes a parabola that could be right side up, or it could be upside down. Our next one, if your highest exponent is a 3, it would be degree 3. We call this cubic. And this was one of our parent functions. It starts off down and it increases, kind of makes a squiggle. It's an odd function. Remember, it's symmetric about the origin. So it might look like one of those. The next one, ax to the 4th, degree 4, we call that quartic. And it actually looks a lot like a parabola, but it increases quicker than a parabola, And close to the origin, for values between -1 and 1, it actually increases slower. So at the bottom, it kind of makes a flatter U, but then the sides are steeper. So kind of like that. It could also squiggle in the middle, so it might do something like that. A fifth degree polynomial we call quintic. And it looks similar to our cubic function, but it also increases quicker for x values greater than 1, and between -1 and 1, again, it's a little bit flatter than x cubed. So it kind of is flatter in the middle, but then steeper on the ends. And it can be increasing or decreasing, and this one can also squiggle, so it might do that. And the last thing we will do in level 1 is look at some functions and determine whether or not they're polynomials. So remember, the coefficients, or the numbers in front of the variables, can be any numbers, positive, negative, decimals, fractions, but the exponents have to be whole numbers, so they need to be positive, 0 or greater. So looking at this first one, it does meet the requirements, so it is a polynomial. And it has, since it is a polynomial, its degree is the highest exponent that shows up, which is a 4. So it's degree 4, and a degree 4 polynomial we call quartic. The next one is not a polynomial because it has a square root. And a square root is a fraction exponent. So that's actually the same as x minus 3 to the 1/2 power. And that is not going to be a polynomial. We're not allowed to have fraction, decimal, or negative exponents in a polynomial. Our next example looks different from the example in part A. It's in a different form, but it actually is a polynomial. We don't have any exponents that are fractions, decimals, or negative. And if we change the form of this, we could expand it. This is actually called factored form. And it is a polynomial. And we could change factored form to expanded form by using the distributive property. So if I multiply this out, we could multiply that x minus 1 twice, because when it's squared, we write the binomial twice and multiply it out. So I'm going to distribute those x minus 1's, and we get x squared minus 2x plus 1. And then I could distribute that first term to those 3 terms, and we end up with p of x equals negative 2x to the 5th plus 4x to the 4th minus 2x to the 3rd. And that is called expanded form. And those two forms are equivalent. They represent the same polynomial. It's just written in 2 different ways. And there are going to be times when we will change factored form to expanded form, but sometimes it'll be too much work and we won't need to. If we want to know the degree of the polynomial, the only thing we need is the term that has the highest exponent, that leading term with the biggest exponent. So if we look at that first term, it tells us that the degree of this polynomial is degree 5. And its name is quintic. And when we first looked at this polynomial, we didn't know what the first term would be, but without multiplying it out, we could figure out by looking up above that x would be squared and then multiplied by x cubed, which would give us x to the fifth. So we could figure out that leading term without actually multiplying the whole thing out, which would tell us the degree and the name of the polynomial. And then our last example, we have variables in the denominator, so that is not going to be a poly. So it's not a polynomial function if you are dividing by variables, because you have negative exponents if there are variables in the denominator. So that will not be a polynomial. If you think about the graph, it might be undefined for certain values of x, which gives us vertical asymptotes, or places that the graph is not continuous. So that would not be a polynomial function.